In this video lecture, interaction-oriented software architecture patterns will be discussed. Interaction-oriented, as the name shows, it shows the interaction of user with the system and the interaction of one component of the architecture, one part of the architecture with another part. It best supports user interaction in the application, separation of user interaction from data abstraction and business data processing. This means interaction-oriented architecture shows the separation of user interactions from data abstraction and business data processing. It shows the system decomposition into three major partitions which may be fully connected: the data module, the control module, and the view presentation module. Loose coupling between data and presentation. This means the beauty of this architecture is that the coupling is reduced as compared to the hierarchical architecture. Let's take example of layer and subroutine, master slave. There was a strong coupling, but the components, the decomposed components, partitions of interaction-oriented software architecture has a low coupling rate. We have two categories or two types of interaction-oriented architecture. PAC means presentation abstraction control, and MVC, model view controller. Both have some similar features like three component decomposition. Both of these patterns has three components. Both are used for interactive applications such as web online applications and distributed applications with multiple tasks and user interactions. But certain differences, obviously there will be a differences. That's why we have two categories of interaction oriented architecture. PAC is agent based architecture pattern. So systems that are based on agents use the PAC, and mostly the mobile applications also use this. But MVC does not have a clear hierarchical structure and all the three modules are connected together. So PAC is like the hierarchical architecture, but it's not fit in the hierarchical architecture. Like the hierarchical, but it is not hierarchical. Why? Because it is the interaction oriented architecture, and hierarchical architecture is the implementation architecture pattern of the components. So first discuss about the model view controller, MVC. Mostly it is used in the web development for web server side interactive application design such as online shopping, surveys, student registration. User interface are prone to data changes. It supports look and feel feature in the GUI systems. And remember that most of the advanced web tools support MVC, such as Angular, Laravel, and so many other tools support MVC. Now come to discuss the model in the detail, model view controller and pattern in detail. We have the three components, partitions. One is a model which basically show the data. The data are stored in the model, and the data behavior are also analyzed in the model part. view, where user interact directly with the view. So through view, user give input through the interfaces and sees the output. And controller is responsible for taking input, processing the input, updation of data, and then selection of data, fetching of data to a view again. So that is the task of the controller. MVC 1, which is a version of MVC architecture, where a system is simply decomposed into two systems. Control view. Module takes care of the input output processing and their interfaces. So MVC 1 combine the controller and view together. Basically these are separated, but consider it as a one part. And model as a separate, which is responsible for all the core functionality and the data. But for large system, complex GUI application, it is better to separate and represent separately the control and view. So GUI example for MVC 1, the view has a GUI interface with two text fields. The user enters a number in one text field and accumulated summation is displayed in other. Means one for taking number as an input and other for showing the summation output. The summation is held in the model view. Notify the register GUI component of change. So data in the data model of the MVC architecture is active rather than passive. This means the data in the model is active, which means it is processed and stored in the data model. MVC 2, further development for MVC architecture. So MVC 2 is further modified form of the MVC 1. Three components are the model, module, view and controller. So basically we have two types of MVC frameworks, 1 and 2. So here controller and view are taken as a separate components, partitions. So the model view provides all the core functionality and data supported by database. View module display the data. Controller module takes input request, validate the input data, initiate the model, means it initiate the model, and view module and their connection. So this means the controller task is to initiate the view and model. It takes input from view, gives it to the model view, and then get back the value from the model and display it on the view. So this is the core function of the controller. For web development, we develop the software in three different development tools. For model, we use a particular database which has a data dictionary and all associated tables. For controller, we use some development platform which is also known as a backend development tool. And view is the interface designing using some particular tools. So all these three combine and give a software system. But what is the advantage of MVC here? Actually, as I stated in the previous slide, that there is a less coupling. The separation is clear and less coupling. Whenever we need to modify or reuse any of the partition of the component, we can do it easily. We can replace the view part, we can replace the controller, and we can replace the model part. Due to the loose coupling, the developers get a chance to replace anytime any of the whole component, whole tire. And this is due to the reason that day by day there comes more advances in the technology, and the controller, the existing controller, sometimes does not support the latest advanced technology. Thus we rely on the modern technology and we need to replace the controller, but kept the model as such. Why? Because replacing the data is not easy. So mostly we replace the controller part or view part, but we can also replace the model part by kept controller and view as such. This is the MVC 2 class diagram. We have a model and this is a controller and view, and this is a database. So database is actually a server, data server, where data lies, but which of the component is responsible for data storing and data manipulation? Model view. Applicable domains for MVC architecture: interactive applications where multiple views are needed for single data model. Whenever we want to design a system with multiple views, so we can easily do it with the MVC architecture. So this means a same data model is same, the data structure, the structuring of data model is same, but with the same data model we can have multiple views possible. An application with a clear division between controller, view and data modules, as I stated. And benefits are that many MVC vendor framework toolkits are available. This is a benefit. So we can easily adopt MVC using modern tools. Multiple views synchronized with the same model, data model. Easy to change or plug in a new interface view. Yes, as I stated already, this is a very effective for development if graphics, programming and database development professionals are working in a team in a design project. This is a very important point, because all the developers or all the persons, stakeholder included in the development process have not a same expertise. Some are expertise of the graphics designing, front end expertise, they get front end expertise, and they have quite a lot of experience in front end designing and they get job for that purpose. Some are the backend developers, good developers, and some are the database developers experts, both developers and DBA. So whenever they start developing, they can independently start on the project. Why? Because of the MVC framework. As there is a less coupling, which means there is a less dependency of the one component on the other. Yes, they combinedly give a software system, but there is no dependency. Independently, all of the team members work in parallel on all the three different components. and at the end they do integration. But there are some limitations, such as it is not suitable for agent-oriented applications such as interactive mobile and robotics application. Because mobile system does not support a model view. So for mobile application and real-time systems, robotic application, we will use the PAC model. Multiple pairs of controllers and views based on the same data model make any data model change expensive. So it is quite expensive in terms of cost. The division between view and controller is not clear in some cases, like in MVC 1. So tools that support MVC 1 are sometimes difficult to distinguish. So the view and controller are sometimes difficult to distinguish. Now come to discuss the PAC, presentation abstraction control. The mechanism is same, the components are same, but the purpose is slightly different. How? It was developed from the MVC. So this is actually developed from MVC. Why? Because MVC does not fit in all the software applications. So developed from MVC to support application requirement of multiple agents in addition to interactive requirements. System is decomposed here into hierarchy of cooperative agents. Each agent can have maximum 3 components: presentation, abstraction, and control. Controller is the same as like MVC. And abstraction works like a model, but it is different from the model. And presentation is like a view. So presentation and control are mostly same. Working is also same, but abstraction is quite different in purpose. PAC is mostly suitable for any distributed system that are based on agents, and all agents are distantly distributed, and each agent has its own functionality with data interactive interface. This means when we talk about the agents, especially in case of distributed environment where the agents are separated, the agent client sides are separated, and each agent is active and independent and has a specific functionalities with the data interactive interface. So this means PAC is applicable for those systems where the system is distributed in agents, where clients on each agent side has a separate distinguished features, functionalities, control, having interactive interfaces. Control component is a mediator between the presentation component and abstraction component. What is the purpose of presentation? Taking input and showing output. Abstraction is for the data, and control is the program component which act as a bridge, as a mediator in these two components. There is a loose coupling between presentation and abstraction. Obviously, we are talking about interaction architectures, and this is the beauty of interaction architectures, that there will be a reduce or less coupling. So this is the generic example. We have multiple agents showing in the hierarchy. As I stated, previously in this lecture that PAC work in a hierarchical fashion, hierarchical way, and in each hierarchical level we have different agents working together. This is the top level agent, intermediate level agent, and this is the bottom level agent. So this top level is interconnected with intermediate level agents, and then this is connected to bottom level agents. Now how PAC works? This was a diagram, but how it works? So controller of one agent is communicated with the controller of another agent. So this is on the top level and this on the second level. So controller on the top of the hierarchy is connected to the controllers of these agents on the second level. So, example, let us suppose design a desktop presentation application that can browse and display presentation pages in a graphic document one at a time. Agent 1 has a connection to data repository, which is the document file, points to the current page in the document. Agent P1 can display the current page in a specified format. Let's see. This is agent 1, this is agent 2, this is agent 3, 4, 5. Different agents are connected from different sources, and through controller all these agents are connected. This is presentation which shows the interface, interactive interface, and this is the abstraction which shows the data repository. But remember that it is not dominant as much as a model component. So this is the PAC example class diagram. Controller is connected to presentation and abstraction, and through controller all agents are connected. So what is the responsibility of the controller? So responsibility of controller is to get request and get response. So getting request through the presentation component, and then get response from the abstraction part to the presentation part is also responsibility of controller. And what abstraction do? It goes to the first page, last page, previous page, next page, etc. So all the associated data resides here. This is the PAC sequence diagram. We have two different agents, and one agent is connected to other using this controller. So C1 get response from the request from the C4 of the other agent, and all the activities are initiated by the controller. So controller update abstraction component and show it to the presentation. Applicable domains of PAC architecture. Suitable for interactive system where the system can be divided into many cooperative agents in a hierarchical manner, and each agent has its own specific assigned job. Suitable for agents with loose coupling. Benefits include support of multitasking and multi-viewing. It supports agent reusability and extensibility. Easy to plug in new agent or replace an existing one. Support for concurrency, or parallel execution. But limitations are extra time lost due to control bridge between presentation and abstraction, difficult to determine correct number of agents, complete separation of presentation and abstraction by control in each agent generates development of complexity. So connectivity of different components together in a loose coupling environment become a problem. So this was all about the MVC and PAC architecture. So hope you understood. Thank you so much for watching my video. Thank you so much.